company makes computer chips from square wafers of silicon. It wants to keep the side length of a wafer very close to 15 millimeters, and it wants to know how the area of the wafer changes when the side length x changes. So we got area and we got the side. Find a prime of 15 and explain its meaning. So to begin with, first we need to find the area function. And since they're square, and they have, let's make that look a little bit more square, and they have a side of length x, the area function is pretty straightforward. It's just x squared. So a of x is x squared. They want us to find the derivative of a and explain its meaning in this situation. So a prime of x, just applying the power rule, gives us 2x. And a prime of 15, when I plug in 15, gives me 30. Now, explaining what it means, whenever you're explaining what a rate of change means, it's always good to know units. Remember, a prime is just a derivative, so it's the change in the area with respect to the side length. So change in a over change in the side. The area, if we're dealing with units of millimeters, is millimeter squared, and the side length, they told us, is in millimeters. So if we're trying to explain what this means, pretty much means that we got the rate of change of the area with respect to the side as 30 millimeters squared per millimeter. In other words, when the side is 15 millimeters, the area is increasing by 30 millimeters squared per millimeter. For a wafer that's 15 by 15, the area changes with respect to the side by 30 millimeters squared per millimeter. Every millimeter that I increase that wafer by on the length, the side, the area will increase by 30 millimeters squared.